So let me just recap what I wrote here. So basically, today we're going to be talking about the multiplication of polynomials. Last time we did the addition and subtraction. We identified polynomials in detail, polynomial types, degree. We also talked about terms and everything else, like terms, unlike terms. Today we'll see how to multiply polynomials. Again, polynomials are just algebraic expressions, meaning expressions with variables and numbers or constants, but without any of this. No negative powers, no radicals, no powers that are fractions or decimals, and no variables in the denominator. So these are not polynomials. So if you see this in an expression, it's not a polynomial. Polynomial are just powers like 1, 2, 3, 4, 5, or 0 without any of this. So to multiply a polynomial, we need to review the first rule of exponents that we learned the other day. What is x to the power a times x to the power b? What is it?
X to
Okay,
power a plus b.
that's right, a plus b. This is very important. So since we're multiplying polynomials, this is a multiplication. So this is the main rule we're going to be using today. So technically, this is a multiplication of a monomial and another monomial. One term times them, you add the powers. But we're going to see more cases when you have maybe two terms here or three, two terms here or more. We're going to see how to multiply the whole thing. So that's how multiplication of polynomials work. Same base, add the powers. First, let's start with monomial, okay, times another monomial. Again, we talked in detail about the naming and the types of polynomials in the previous class. So we learned how to name them based on how many terms they have. So a monomial has one term. Let's times that by another monomial with one term. So let's say 2x to the third times, or we can just use a period, 3x to the fourth. The reason I'm using a period for multiplication is to avoid the confusion of the variable x with the multiplication sign, which looks like this. So instead, we use just a period, or in some certain cases, we just use parentheses around both polynomials without the dot. So that means the same thing. So it's still a multiplication here. So that's kind of similar to this. So basically, we're going to multiply these two as we saw last time with simplifying expressions. What is this equal to? We times these two together.
7. Oh, what do you mean?
First, we need to multiply.
Yeah, 2 by 3 is going to be 6. X by power 7. Yeah?
That's right. So 2 times 3. 2 times 3. Also x3 times x4, as we did last time with simplifying expressions. And the powers add up according to this rule. So that's 6, 7.
7.
Okay, so that's basically how easy it is to multiply a monomial, two monomials. We just add the powers times these. If you have any coefficients here, times them first, and then add the powers. You could also be, let's say, monomial. Let's say 3x to the second, and before that, could be monomial multiplied by a binomial. How many terms does a binomial have? How many terms are in a binomial? Bi, that means?
2.
That's right. So if we take a monomial here, and we multiply that by a binomial, some two terms, for example, let's say for x to the third and maybe some 8x. Okay, so a multiplication here between this term and these two terms. What do we call that property again? When you distribute, the property has a name. What is it? When you multiply, what is that property called?
I don't understand the question.
When we times, when you multiply here, we saw this on the first lecture. When you times, what is another name for this property? It's multiplication or it has another name of another property. What is it? When you times? It's called the distributive property.
Mm-hmm.
When you distribute, or you multiply, let me respond to someone here trying to join the meeting. Okay, so I want to hear from everybody else. Please wake up, engage. I don't want to be talking to one person only. So again, the property is called the distributive property. That's basically when you multiply this way and then multiply again. The distributive property, as we learned on the first day. So 3x to the second times this term. First, we're just going to write the terms next to each other, and later we're going to multiply them. Then plus this term times this term, plus times plus is plus. So 3x to the second. Okay, 3x to the second times 8x. What's the power of this x again, by the way?
1.
Power is,
Oh.
That's right, very good.
Mm-hmm.
So we distribute it now. We're going to multiply these two together, just like we did earlier here, using this rule. What is equal to? Would be 12
X power 5.
That's right, we add the powers plus. Multiply these two, that's 24.
X power 3.
That's right, power 3. So if you don't see a power over a variable, that's an invisible 1. Okay, so when you multiply, make sure you add the powers. Makes sense, everybody? Bassar, Jorat, Amin, Miss Marsara, Rafalina, Robin, Tisha, are you guys on board? Can you hear me?
Yes, yes.
Yeah.
All right, please feel free to engage and respond to my questions and let me know if you have any questions at any moment. Okay, that was a mono times a monomial. Now let's see what happens if you have, let's say, another example, maybe some negatives in here.
So that's the answer?
That's right. So basically that's the answer.
And that's it?
Yes, so these we can't add them as we saw last time when we added polynomials. These are
Because they have different powers?
Exactly, so the power is 5,
Oh, okay.
3. So these are unlike terms, we can't add them. Let's look at another example here. Let's say multiply this by 3x to negative 2 minus 5x to the power 3. Same thing, I'm going to be using the distributive property. So we're going to go this way and that way. So let's do the first multiplication. We have negative 2 times 3, which is
negative 6.
That's right. And we have x4 times x negative 2. Again, we combine the powers. If we combine 4 and minus 2, what do you get?
2.
2.
That's right, positive 2. That's the first multiplication. Then we're going to do the second multiplication. First, you're going to multiply the signs. You have a negative term here, negative term. That would be
Positive.
positive. So we're going to multiply
Plus
it.
10.
That's right. And so positive 10. And what else? x4 times x.
X to power 7.
Very good. Can we do anything else to this?
No.
We can.
No.
Not similar. You say x and x, that's good, but the powers are different. It has to be the exact same power. So we can't do anything else. So that's basically our final answer. Only multiply, only combine like terms. When you add or subtract, you gotta have the same power, same variable to the same power. Let's see. So multiply polynomials, we did that to polynomials. You may have, so the next case is when you have two binomials. So this is how to multiply two binomials. Okay, so binomial times another binomial. Each will have two terms. As an example, so say 3x minus 2. Let's multiply that by 5x to the second plus 1. Okay, so again, when you multiply, we can use parentheses around both polynomials or binomials. When you have more than one term, you have to include them in parentheses. So this has to be in parentheses, this also in parentheses. So basically, this is a multiplication. You don't even need that multiplication sign. Again, you may be confused for x. When you don't see anything between two parentheses, that's a multiplication. Okay, so we're gonna multiply these by these. So we're gonna have a total of 4 multiplications because you have 2 terms and 2 terms. You expect to have 4 multiplications. Here we had 1 times 2. 1 times 2 is 2. That's why we had 2 multiplications. For this one, we had 1 multiplication. One term. So 1 times 1, you had 1 term. In this case, we're multiplying 2 terms by 2. So 2 times 2 will be 4. So we expect 4 multiplications like these. So let's first write all the multiplications like we did here. And then in the next step, we're going to multiply them and combine the powers. So here's what you do. You go to the first term and you got to times that by both terms of the other polynomial. And once we finish with that term, we're going to go to this one and repeat the same thing. So we're going to take this, multiply by that, and also by this. Let's write them out first. So 3x times 5x to the second.
Is 15x to the third.
That's
To
right.
the power 3.
Exactly. If it helps, if you make it easier, you can always write them down first. Write all your multiplications down first and then multiply in the next step. If you feel comfortable or confident to do it right away, that's fine. You can multiply right away. 3x times 1, both positive. So
3x.
That's right. So 3x times 1. Then you have negative 2 times positive 5x to the second. So negative times
Negative 10x.
Squared.
That's right. Always write your sign first, and then 2 multiply x to the second. So 2 times multiply x to the second. Finally, negative 2 times positive 1, and the sign will be
Negative.
that's right.
Negative 2.
Sign, negative positive, then 2 times 1. Okay. Now we wrote all the multiplications as we expected. We have 4 of them. 1, 2, 3, 4. Why? Because we had 2 terms times 2. 2 times 2 is 4, so we expected 4 multiplications.
Wait, you didn't put 5 before x to power 2, but you didn't have to? I mean,
say again, which multiplication are you talking about?
yeah, the second part. I mean, negative 2 multiply by 5x
Oh
to
no, we
power.
don't need that 5. Negative 2 times 5x.
Oh, okay.
Negative times 5. Also, there's a little mistake here. 3x is here times 5x to the second. Not third. We don't add yet. Now we're going to multiply each one of these. So 3 times 3, that's 15. Again, the power is invisible, it's 1. So x to the third. 3x times 1, and if 8 times 1 is itself. Identity property of multiplication. 2
10x.
5, right? 10x.
Squared. Double.
That's right. Then negative
Minus 2.
Once you do that, you try to combine like terms. Do we have any like terms to combine here?
No.
That's right. All the terms have different powers, x3, x1, x2, and we have a constant here. We only combine terms that have the same power, same variable. We don't have that here, so that's it. There's much we can do here.
Mhm.
Nothing much you can do here. You can possibly arrange these from the highest to the lowest. You can bring this over first. Start with the highest power.
In
You
descending.
can arrange the terms in a descending order of powers. So if x to the third, bring this over with the sign, negative x. Negative 10x to the third, second. Move this back here. Gonna move this back with the sign, positive 3x1. And bring this constant here. What's the degree again of this polynomial?
3.
That's right. The degree is the highest of all.
The highest, yeah.
That's right. That's 3. So that's a final answer. You don't need to do anything else because all these terms are different. Okay, so some people. Just respond to some students that are having a hard time joining the Zoom link. Let me email them again. Okay, here. All right, so that's basically how you multiply. Is how you multiply binomial. Let's now try another problem. If you have binomial, not binomial, but monomial times a trinomial. So 3x to the 4th, for example, you want to times that by a trinomial. Something like x to second minus 5x plus 4. How many multiplications are we going to have here?
3.
That's right. We times in 1 by 3. That's correct. 1 times 3. 1 times 3 is 3. So you expect 3 multiplications. So we're going to distribute this 3 times. So we're going to go this way and do it for all the terms. 3x to the 4th times x to the 2nd will be
3x to the 6th.
exactly, so 3. There's an invisible 1 here. You can think of it as 1 here. So 3 times 1 is 3. X to the 4th times x to the 2nd is x to the 6th. And second term, the sign first, positive.
Negative 15x to the 4.
Not the 4th.
5.
Oh, 5, yeah, I'm sorry.
Right, invisible 1. Finally, positive times a positive. You have 3
12.
times 4 is 12.
12x to the 4.
X to the 4, yeah.
You have x4, there's no x here, so that stays the same.
4.
Just x4. No like terms, all the powers are different, so that stays like that. And this works the same way, doesn't matter how many terms you have, you just multiply all of them, and at the end, combine like terms and simplify if possible. Okay, monomial, we did all cases. What if you multiply the trinomial by trinomial? How many multiplications will you have?
6.
If you multiply a trinomial by another
Oh,
trinomial,
9.
it'll be 9 terms.
Mm-hmm.
So it'll be the same thing. So just multiply the
3 times 3.
Yep. The next thing is, let's see how to square a polynomial. You have 2x, say plus 3, to the second. So this is basically a binomial to the second power. So in order to multiply this, we first need to break it down, to expand it. For example, when you have 5 to the second, what is that equal to? If you break it down, would be?
2x plus 3.
No, just this one here. If you have 5 to the second, 5 times 5.
5x, 5x.
And I'm talking about just this one. We have 5 to the second.
5 times
What?
5.
45.
25.
25.
I can see it, it's my phone is wrong. Okay.
Yeah, so anything to the second power is basically that thing times itself.
Mm-hmm.
Same concept applies here. So we have something to the second power. If we expand it, it will be just this times itself. So 2x plus 3 times itself. Times itself. Okay. Now, it kind of looks like this, as you can see. So we have a binomial times a binomial. We can have 4 multiplications. So let's expand, or actually let's multiply.
4x is the first one, no?
That's right. So we're going to multiply
Times 2.
this first. That would be 2x times 2x. That would be
4x
4x
4x.
to the power 2.
second.
Exactly. Because we have an invisible
Okay.
1 here. That would be
Yeah.
1 plus 1, which is 2. And 2x1 times 3,
6x.
Yeah.
right? 6x. So we're done with the first term. We're going to go to the next one and do the same thing. We're going to multiply it by this and also by this. So
The same things, yeah?
that's right.
It's just opposite. Yeah. Just like plus 6x.
6x.
Nine.
Plus 9. Oh.
Right? Plus 9. Can we do anything else here?
Yeah,
Yes,
we can add
6x plus 6x
12x.
These are the terms. We can combine them. So we can combine these two.
Yeah.
So x stay the same.
Plus 12x plus 9.
That's right, plus 12x. So when you combine like terms, make sure the variable and the power are the same. For example, here they're both 1 and 1, x and x. When you combine like terms, basically you're combining the coefficient to have positive 6 plus 6. That will be plus 12. To the 1.
Mm-hmm.
And finally plus 9. So when you combine, we don't add the powers. We only add
Mm-hmm.
leading coefficients. But when you multiply, this is a multiplication. When you multiply, that's when you add the powers. That's how we got 2 here. And you times the coefficient. 2 times 2 is 4. And that's basically the final answer here. Nothing else to do.
Let's.
Okay, does that make sense to everybody?
Yes.
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 Very good. What else? Let's see if we can do another problem. I believe we have, we're gonna learn another one, another rule. This is a special case here. We're multiplying binomials. Say you have x plus 5. You want to multiply that by x minus 5. Again, kind of like this. Binomial times binomial. This special one, something special going to happen here.
X squared. Squared is the first one?
Yes, that will be Please, all right, one, two, three, signing.
Where are you now?
Let me respond to students who's having an issue signing in.
Oh, okay. I'm looking what you're writing because I said, what is
Yeah.
I have a phone and I cannot see very well sometimes.
All right, back to this. So, as we said here, we have binomial times a binomial. Something interesting is going to happen here. It's kind of like these, binomial and binomial, but this one is a lot special because it looks like the same thing, but the signs are a plus, we have a minus. So what do you do? I go x to the second,
Okay.
then x times -5.
Negative 5x
That's right. Then positive 5.
plus 5x minus 25.
That's right. Minus 25. So be careful you use signs here when you multiply. So when you multiply two terms, first get the sign. Plus times plus is a plus. Plus times a minus is a minus. Okay, now that we did that, can we simplify this a little more?
Yes.
Okay, how?
Combine -5.
I mean, it's gonna disappear, minus 5x and plus 5x, or
These will cancel out. They're similar terms because they both have x to the power 1.
yeah,
When we combine the coefficient. We have -5
yeah.
opposite. So -5 plus 5 cancel each other out.
Mm-hmm.
0.
So we will just have x to the power 2 minus 25.
That's right. So these two cancel out. Be careful before you cancel out. Here it didn't cancel because it's the same sign. We add, but if you have opposite signs, we cancel them. So we have x to the second. We have -25. That's basically how you multiply when you have a case like this. Is there a quick way to go from here to here directly without going through this middle step? What happened to the x? We just
Yeah.
squared it, right? We did 5 and we squared it with a minus. Okay, we have plus and the minus. We take the minus, not the plus. The middle ones cancel out. So next time you see something like this, you don't have to distribute it and combine like terms. You can just you can go directly from here. Here's another example. So if you have x minus 3, x plus 3. Let's do this right away without having to distribute and combine like this.
X to the power 2 minus 9.
That's right. So it looks like the same thing. You must have opposite signs. If it's the same sign, this will not work. Like this, if it's the same sign, you will have 3 terms or more. But here, if it's opposite signs, same terms inside. So just take the first one, square it, put a minus, always a minus, and take the other one and square it, you get 9. That's right away. This is a special one, special rule. It's very useful. We're going to be using it in the future for factoring. We're going to be using it to go backwards. That's what we call factoring. When you go from here to where you distribute or multiply, but the other way is called factoring. So remember this one, it's going to be very useful. In general, if you have, let's say x, let's just say a minus b, a plus b, in general. What is this equal to? Again, in one step, it kind of looks like this. So this will be
A to the power 2.
that's right. A squared.
Negative b to the power 2.
Very good. That's it. So this rule, we're going to take advantage of it in the future. We're going to need it to do a lot of things. So, so if you see a setup like this, make sure the numbers are the same, but you have opposite signs. If you have that, take the first one and square it, put a minus in between, and take the second one and square it, okay? The difference of 2 squares.
Professor, can we get those pictures where you're gonna post it, or it's already there? So
Which-
like the
This
picture
problem.
with, those problems, what you're writing.
You mean this here, this lecture?
Yeah, like the
Yeah.
screenshots or something.
Yeah, I'll upload the whole video. I'll upload the whole video.
Oh, okay.
What we did last time was also uploaded. If you go to Blackboard,
Mm-hmm.
I believe I did that video. So everything we do in class, I record it and I re-upload it so you can go rewatch it whenever you need to. That's basically how trinomials work. So just multiply and add your powers. When you simplify, make sure you have the same power, same base in order to combine like terms. Let's see if you can do another problem. All right, so any questions, everyone, at this point? Everybody got this?
Yes.
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 All right, please let me know if you have any questions at this point. We did all the cases here. Let's see if we, another case might be something like this. You could have multiple variables, not just x. You could have this, let's say 3xy. That's a monomial and could be multiplied by xy minus some 4xy plus right, you may have something like this. So basically we're multiplying a monomial by
Can you say again? I'm sorry.
By one?
Basically you're multiplying this one by a trinomial. So this is a trinomial. So 1, 2, 3. We have one monomial, so we can say monomial times so monomial by trinomial. Doesn't matter if you have multiple variables, it's the same rule. So let's see how to do this one here. So we're going to times these two first. So 3x5 y4 times y2, x2 times y. What is this equal to if you multiply these two?
18. X.
X to the power 7,
7.
Y to the power 5.
5.
Okay. Okay, basically multiplying 3 and 3, x and x, y and y. Then you go to the second term and do the same thing. But first you gotta get the sign. So we have a positive 3 here, times the next.
Negative
Negative 12.
We have 12, that's right. x5, x3
to the power 8.
8. Yeah.
x to the power 8.
Y4.
That's right, the y stays the same because there is no y here.
Mm-hmm.
That stays the same. Finally, this term,
Plus 15.
that's right, positive 15.
X to the power 5.
Right, xy.
Y to the 6.
There's no x here, so this stays the same.
Mm-hmm.
X to the 5 and Y to 6.
Y to the 6.
That's right, y to the 6th power. And that's pretty much how you multiply polynomials, monomial, trinomials, binomials, doesn't matter how many terms you have. So remember this rule, we're gonna get back to it. We're gonna use it in the future. And basically, also remember the rule here, add your powers as you multiply, make sure the base is the same, add your power. If you don't see a power, for example here, that means there's an invisible power 1. And in order to combine like term, make sure the powers are the same. If they're not the same, for example here, then you can't add them. But here, since they're the same, we can combine them. And remember, when you combine like terms, you're actually combining the leading coefficients. Sometimes they cancel out, sometimes they don't. +6 + 6 is +12. But here, it's -5 + 5, so 0. That's why these two cancel out. Two opposite things cancel each other out. Be careful with your multiplication signs. As you distribute, always get the sign first and then get the value. Okay, that's pretty much it for this lesson of multiplying polynomials. You'll see plenty of practice problems in the homework about this. So practice as much as possible, get used to it. And with that, let's show you the homework. Let's go over to the homework and the lesson plan. Any questions, anybody, before we move?
No, just attendance,
No.
right?
Yeah, we're going to take the attendance in a moment. And also, gonna go over to Blackboard, to the discussion board. If you haven't done so already, please say something on the discussion board right now. It's again important for attendance and your participation. So let me stop here.